Well, it's that time of the day when the crows are flying around outside and settling on the wires and all the neighboring rooftops. My cat just really wants to hang out with the crows, but he does not have roof access. Welcome back to the shop, everyone. Got a little bit of crows happening outside. I just saw Tuco, my cat, doing his thing where he rushes around looking for a good view, but I'm not exactly sure where he ended up. Yeah, this is a good time for sky and birds here. Oh man, so welcome back. As usual, this is my kind of live stream hangout while I work on stuff. So, you know, it's a place to talk about electronics and reverse engineering and cats and whatever we can do to find the intersection of technology and stuff that's worthwhile to do with that technology. Yeah, I don't know. I go on about how pessimistic I am about tech a lot on this because, to be honest, it's like kind of hard to find places to vent about that, and you know, like I can like tweet about it, but I don't like using Twitter. I can use Mastodon, but I don't necessarily like filling Mastodon with just like random negativity, which isn't what I plan to do here either, but it's I feel like here I could at least have maybe a real-ish conversation about stuff, whereas it's been harder to find like small groups where that's more possible online lately. Maybe we can do some more of that, but anyway, we can talk about other stuff too. I obviously do a bunch of technology. I just feel like a lot of the sort of usual stuff that people do with them, like building startups and trying to make Google larger and, I don't know, just like weird flashy things. I mean, they're nice sometimes, but it's kind of hard for me to get excited about stuff. You know, just given all the negativity that technology, I mean, negativity that sounds like I'm just interested in like keeping everyone feeling positive or something. But no, I mean, what I'm actually trying to talk about is I want to work on applications of technology insofar as I can work on applications of technology. I want to work on applications that have an ethical and hopefully even useful use. So, and it's hard to find that these days. I feel like I managed to work on a bunch of stuff in the past that was like varying degrees of useless, but didn't actually, you know, didn't actually hurt very many people probably, but also didn't really do any good. So, and then I find myself to be really like incapable of all the like really high-level human skills that seem to be necessary to cause real change, because everything real is really like a political or management problem at some point. Anyway, that's way into the depressing weeds. I could answer Station 240's question, what is Coastermelt? That is an older project of mine. I guess GitHub was telling me it's been 4 years now. That was actually my first edited video in the current series that I've been doing. So, but to actually answer your question about what it was really just the idea that I wanted to do an open source firmware for an optical drive, in particular a Blu-ray burner. And the kind of far-reaching goal here that would maybe be possible, but maybe not, like kind of hard to tell how possible this is. The far-reaching like goal that would be really nice to get to would be the ability to burn arbitrary patterns onto a disk. Because, you know, you get a blank disk, it's already got a spiral laid down in it, but maybe you can use that spiral as a reference and then kind of burn somewhat arbitrary patterns given whatever the limitations of the hardware actually turn out to be. And then use that to create potentially like interesting optical diffraction patterns. I thought it would be cool to make some kind of hologram that you could bounce like a single coherent light source off of, and then it gives you like a projected 2D image. So that seemed like it might be possible, maybe, kind of hard to tell. But yeah, it was basically a project to do a reverse engineered kind of documentation of the features of the system on chip that we would need, and then use that to develop some open source firmware. So yeah, that's I documented the sort of whirlwind of work that I did on that project so far in these 2 edited videos now. And really the place where I kind of left that for a while was having the tool set that let you read and write memory and do some kind of basic debugging stuff on the drive, but not a lot of documentation about what the hardware is actually doing. I think I found some registers that would let you move motors around in some very basic ways, but I hadn't done the reverse engineering necessary to actually do anything useful with the hardware, really. And I mean, part of the reason I left it was that a bunch of stuff in my personal life exploded and I just couldn't really work on it for a while. But then part of the reason I left it was that I was hoping to leave an opportunity for other people to contribute to the project, since it seemed like maybe a fun time to jump in if I were someone else. But, you know, we could also do a lot more work on it and make it more fun to jump in. So I think someone was saying last time that if it was possible to make a somewhat arbitrary mark on the surface of a disk using this firmware, then it would be a lot more compelling. And yeah, I totally agree with that. That's certainly true. Tuco is right here, and I can't tell whether he wants to just chirp at birds or bite USB cables in half. Well, it's some interesting things to respond to. So Station 240 is down on Internet of Things stuff, saying that it's useless given enough time. Yeah, yes and no. I mean, I think that it isn't inherently bad to build like devices that are interconnected. I mean, I thought it was like potentially useful to connect like relays to your parallel port back in the 90s, and I think it's still like useful to actually interconnect things. I think the thing that's frustrating about a lot of the current technology that people are building in those spaces is the way that the hardware is actually attached to a business model. So you don't really have just a device that you can either buy or build, and that device does something, but now it's part of this service, and the service has to have some like monetary way of surviving long term. And I mean, there is a gray area there, because like pretty much any piece of technology does need to be maintained, and especially in the case of software, there's actually, you know, it's like a public health risk having unmaintained software out there on the internet. So, you know, not literally, but I mean, that's how we end up with, you know, massive internet insecurity problems, is having lots of unpatched hosts out there with vulnerabilities. So, you know, I buy that there is this necessity to keep some amount of our software patched and up to date if you're going to use it online. But that's a pretty far cry from just not letting people use anything, even in a disconnected fashion, after the company who made it goes out of business, which is the case for a lot of hardware now. And that's certainly a problem to worry about. And that's something that maybe I figure that, you know, us individuals can fight back against in some small way, either with what devices we choose to bring into our lives, or with, you know, being able to take devices that we find or devices that are no longer useful in their original capacity and to do something new with them. And so we've had some inklings of projects like that on this channel. We could certainly do more of that. Yeah, and I guess Station 240 just got on that too, that like, yeah, basically the two sides are either you're going to have security holes or they're going to intentionally make the device useless. You know, if it's not actively maintained, you end up with one or the other. So really, I mean, I think the answer to that is to help distribute the maintenance so that it's no longer the responsibility of that one company that sold you the device, but it's something that you can distribute among repair professionals and like community bulletin boards and hobbyists and enthusiasts. And that's something we're seeing now with, I mean, you know, the media, I think, is maybe spinning things in ways that are like sensational and maybe less accurate in a lot of these cases. So like, for example, there was some change, and you know, I don't know the technical details, but there was some change in the recent like Apple products where you can no longer, as an individual, repair, you know, like the top case and the motherboard at the same time on the laptops. I don't know the details of how this now applies to laptops, but like this has been true for like iOS phones for a long time, and it's been because there's a cryptographic pairing between the logic board and the processor that's right behind the thumbprint sensor. And as far as I know, like, you know, they didn't set out to create like this evil DRM system that, you know, screws over their customers. Like that wouldn't actually be productive. But what they did do is they made a whole bunch of technical choices that, you know, improve the security of the platform, but then they didn't take the necessary step of actually enabling individuals to fix their own devices. And the combination of those two things, as far as the customer is concerned, is basically the same like evil thing. But like the way the media is describing it, I don't think it's actually accurate. I don't think it's actually like a DRM feature. I think it's a missing tool that would have been necessary to rekey the security processor. Yeah. Tuco is here enjoying the birds. I like giving you the bird stream, but I think the Tuco stream is pretty great too. So the regular Tuco Flyer camera is slightly offline right now. I can show you what's going on, but it's on the table over here. This is a problem we were talking about a little bit on the last stream, but it's a combination of a couple things. I wanted to replace the DC to DC converter. It wasn't actually failed, but it just seemed kind of sketchy, so I wanted to replace that. And I needed to do like a minor repair to fix the LED wiring on the Flyer. Neither of those really a big deal. But then while I was handling it to try to investigate the LED wiring, the bottom of the Flyer just falls off. So that's the most pressing thing right now. It's in a clamp right over here behind me, and we can't really move it around until I fix it. So that needs doing. So yeah, maybe a good plan for this stream is, you know, we can chat, whatever, hang out. I did want to at least show folks the current status of Coastermelt just as a "you are here," because that is in the title. I don't want to like leave people hanging until the very last minute. But I think the main thing I wanted to do on the stream is to try to fix the Tuco Flyer a bit. So I'm also just like tired and grumpy, so I don't know how long this is going to last, but we'll see. Tuco is going to eat that USB cable at some point, isn't he? Oh yeah. Yeah, I guess Piot and I are probably at around the same longitude or whatever. Oh, Tuco, are you biting USB cables? Just all the USB cables? Jeez. It's a good thing I have most of the wiring in the rack, and like everything high voltage should either be covered in something or put away. Oh, Tuco, you're biting USB 3 cables. Stop that. Dude, no biting USB 3 cables. Jeez. Yeah, I should probably protect that wire, I guess. That was kind of a temporary addition. Oh, now he's hunting flies. I'm just gonna get Tuco B-roll here. All right. Oh, where is he wandering? Yeah, this is not as easy to fly as the robot camera, despite the robot's quirks, because it certainly has some. But anyway, I guess I can use this camera to show you the current state of the robot, at least. Oh gosh, this is an unintuitive camera angle. Yeah, I think Tuco's got something to do upstairs related to those birds, probably. Alright, so I've got this attached to the clamp here. This bottom section is supposed to be attached to the carbon fiber rods. It currently isn't. We need to take a closer look at that. The way this usually works, there's a load-bearing piece kind of near the bottom here, which is attached to the bottom with a couple of screws. And then the LED rings just sort of slide over a fixed core and then just kind of friction fit in place. So I think we have to make sure the wiring is clear, then slide up the LED ring at some point and take those screws off for the bottom. I think we can do that before or after. But yeah, there's going to be a bunch of wires. It's going to be a little messy. Lots of wires. That's a good question from Twitch chat. Trevor2 asks if my cat is named after Breaking Bad. He is, in fact, named after the character in Breaking Bad. I didn't choose that name for him, and in fact, that's pretty opposite to his actual personality. But yeah, we, you know, didn't want to rename him. So yeah, that's where Tuco got his name. And it's a pretty intense character. Doesn't quite match Tuco's personality, but then, you know, when Tuco really wants to get his way and he's, you know, he thinks something important is on the line, you know, he will just actually kill you if he needs to, I think. So, you know, we had these cats I was taking care of kind of recently, and Tuco got in an argument with one of them, and I was trying to separate the two, and Tuco got really mad at me and left me with, is it still visible? A barely visible scar, but that was like a year or two ago now, and yeah, you can still see the scar from that. All right, well, let's take a brief look at Coastermelt. I have a whole bunch of, well, not a whole bunch. I keep saying a whole bunch because I like to imagine that I have this huge stash, but it's like 3 or 4, which I guess is maybe a whole bunch. But I got several of these drives, which are the model that I was using for Coastermelt. I haven't really gone shopping for these recently. I'm told they're a little bit obsolete, so maybe we should look quickly and see what is actually current. Because one sub-project in this might be taking the current work and porting it forward to a new model. Assuming we can still, assuming it's still the same vague code base. It looks like this manufacturer, so the drive is marketed by Samsung, but I'm forgetting, oh, that's right, TSST, Toshiba Samsung Storage Technology. They're the one that actually designed the firmware and the system on chip. So I think they've been around for a long time, and they've had a lot of products that share code. So we might be able to use some of the Coastermelt code in other products, but that's still pretty TBD. All my keywords are different, and it really trips me up sometimes. Geez, somebody is selling this exact model for $150, which is twice what it is supposed to cost, at least. So one thing I worry about is that just the concept of optical media is getting pretty dated, and so it's just going to get harder and harder to find these drives, probably. There are new TSST drives, though. It just seems like this series is pretty obsolete. Yeah, let me show you this. Let's get rid of that overlay, sorry. Yeah, right. So this is the model I was using, the SE506, and yeah, it looks like somebody's selling them for pretty expensive. Like, I would not pay that much for this device. Oh, and what else is there? This is something by, who is this even? I don't even know who makes that drive. But then this one seems promising. This one is like $30. It's a TSST drive, SE208. Seems like, I mean, it's been the same series. This is the SE506. This is SE208. I don't know. I don't know if this is a writer, though. Oh, that's interesting. DVD writer, no reader. Is it not Blu-ray, though? That might be a big difference. Can we find just TSST? Verbatim. Yeah, I don't know. Optical drives, man. They're getting kind of old. Whew. That's like a set-top thing. Maybe Samsung? Well, what chipset do these use? Because they're cheap. Oh, USB 3 here. This is not Blu-ray. This one is a read-only Blu-ray, not a burner. It's possible that just the concept of writable Blu-ray is now dead and no one sells these anymore except at a huge markup. Well, that's a bit of a thorn in the side of this project, isn't it? What about eBay? Okay, you can still find some of these on eBay. Like, that's an alright price. That's a great price if it works. That's a bug zapper. That's a bit gougy. That's an album. It's a light bulb. Thanks, eBay. Oh, I didn't mean to click the help button. Okay. And there's also internal, which we could target also. That might be similar because a lot of what I'm doing is at the SCSI layer, so it would be portable to SATA versus USB, but it seems like it would be easier to stick with one or the other, right? Yeah, I mean, the current research that I've done so far is on the Samsung, like the Samsung Toshiba. Yeah, it's just a joint venture between Samsung and Toshiba, I think. Like they have a chipset together, and something like that would be, you know, easier probably than a completely different vendor. So anyway, this might be a bit more of a shopping challenge than just a straightforward buy this one because it's cheap kind of pointer, but all right. It looks like they might still be available if you look in the used market. And then the source code that we had, let's check that out. Would help if I spelled it right. Alright, Coastermelt is a fun way to break your Blu-ray burner. And if you want to see the videos on this, you can see those at Diode Zone. Not there. Let's see, where would I find myself on Diode Zone? I can search for Scanlime. Go to the edited videos. And Coastermelt 1 and 2. I think just searching for Coastermelt here works too. Yeah. So there have been 2 of these so far. I uploaded them to Diode Zone a month ago, but I actually made them like 4 years ago. So. I know the sound doesn't work. So this is not going to the right audio output.
Manufacturing device, but like
internal speakers are not
so tiny, we don't usually think of it as manufacturing. So anyway, it's this device I have. It's a common Blu-ray burner. Well, so what am I doing with this? Well, I'm hacking it. I'm trying to kind of get inside it, and so
there's a bunch of hacking it.
Aligned bits,
this firmware,
but they're not aligned vertically. These are things you know.
Yeah. So this was edited. Like I edited this in this like really frenetic kind of style. I don't know if I would do the next videos in exactly the same style, but it's kind of an interesting ride.
Right after the previous function. The instructions are a fixed size. You often need to,
So, like, I'm talking about how I find the code, how I make some sense of it.
Offset. And Ida got kind of mad about that yet, because I haven't told Ida that, actually, these commands
These
just
are the
kind of
USB
check again
transfers.
to make sure the device is the right version. Device. So you don't really need, like, administrator privileges to write over the flash memory on your... This is how I put it. This first part, indication that I've made a change, are each 100 requirements.
Here we're at the point where we can actually modify the firmware, patch the firmware's like CRC, and then be running the modified firmware.
You could to get the results back. If I could just kind of tap the CPU when it gets to a particular point and have it run some of my code, and then go back to what it was doing, CPU running on the debug host, in this case the Python shell. This guy right here.
Oh yeah, man, I had complicated haircuts back then. I've been kind of avoiding that scene, but yeah, it was interesting at the time.
It talks to the photodiode amplifier. I haven't found so much as a serial bus that communicates between it and the other chips. The other chips seem to only really do kind of high power heavy lifting. The one on the right happens to also control the LED. Then I get a response, or the sim command instruction said it is yet. And I'm only really guessing about what it is based on context.
Yeah, so that's, like, I still did not know very much at the end of this stream. Had the ability to change, the main firmware, but there was, like, some kind of DSP I didn't understand. I didn't really know anything about how the hardware is attached. And then there's another episode which went a little deeper and had some intro music. This was lots of me messing around in Ableton.
Okay, move the head back. Kind of scooted along. Getting the simulator to the point where it was starting to talk to...
I like the editing on this one a little better.
It involved a bunch of distractions along the way. Anytime I came across some code where I kind of couldn't really see at all what it was doing, it was especially
obviously unscripted.
It's kind of shaped like this. It's accessing
very
these
unscripted, but so much editing.
See, whether it's interesting or not. There are like 800 USB cables here. Keeps the simulator.
Oh, I still kind of have that coffee mug.
Personally, think about it.
It's from this kind of hipster shop in San Francisco. It's really faded now.
This chip is the MT1939 system on a chip by MediaTek. It's got an ARM logo on it, so we know it has an ARM CPU. But that's about all you can tell by looking at it. There's no public data sheet. And then 2 small chips by TI that collectively do all of the motor control tasks, and then a power converter from ST. MT1939 chip. What do we know about it? Definitely
that's an annoyance in PeerTube. When it switches resolutions, it likes to start over briefly.
There's some kind of bus that connects
some kind of bus.
I know that there's an 8051 CPU somewhere. I was originally assuming that the 8051 was connected to the USB interface, and then the 8051 connected to
that's the broken
ARM.
Tuco
Using
cam.
some kind of flexible connection channel, so that maybe this whole thing could be replaced by some other interface that knows a different protocol, like SATA. My immediate goal is really just to run this firmware in simulation. That seems good.
That was a very different place I was filming from. Just had this little area with a couple of cameras.
That was the startup sequence that goes through. Oh, there we go. See the
that was a tiny room with no windows, which was also pretty opposite from this.
And up here you can see the USB transaction.
Oh yeah, welcome back from outer space. I assume that's what we mean by space. But yeah, I was thinking about what it would take to revisit Coastermelt, so I was just kind of presenting a bit of what we had before, and now I'm talking over myself for some reason.
I'm going to want to write my own firmware for this from scratch. It'll need to talk to the outside world. So I've been keeping
yeah, right. I don't think I've had any haircuts since this video.
I started out just looking for things that I would recognize in the firmware. Numbers or...
No, I think I was cutting my hair short for a while.
And then I found some stuff like that in this 8051 firmware. And, it turns out the 8051 doesn't
I really like the overhead paper style, though.
I saw this code.
I did some presentations like that.
That worked pretty nicely. Directly to the USB controller in order to send replies back to the computer. When you first plug in a USB device, there are a bunch of standard commands your computer will send it asking it to identify itself. I expected that if the 8051 processor was
Oh
handling
yeah, my
all the
Tuco is
USB
definitely way more
communications,
chill than
that it
Breaking
would
Bad's
have
Tuco.
the code necessary to respond to these commands from your computer.
Tuco's
USB
just hanging out on the
descriptors
desk
are
chilling.
things like
It's
the name
cool.
of the device, the manufacturer, what driver to load, what kinds of input and output pipes it has.
USB
That data is all
descriptor,
formatted
outer
in a very
space.
specific way, and it's usually pretty easy to
Yeah,
find
no, I
in
still
the
have not
firmware image.
updated
I
IDA
didn't
since
find
this.
that
Like,
data in the 8051 firmware. I found that data in the
I
ARM
wouldn't
firmware.
probably
thought that the
buy
ARM
a copy of
processor was
IDA. I would
taking
probably,
those USB descriptors and kind of
and I'm trying to
packaging them up
spend
and
more
putting them
time
in
on
shared memory
software
into a place
that's
where the 8051
not
could
IDA.
access them.
It's like
I didn't
Binary
really
Ninja or
find
Vidare.
evidence to support that. I think the role of the 8051 processor is actually much stranger. I can see the main ARM processor actually initializing
Oh,
the
that's
USB
right. Yeah, the
controller.
8051
actually
was
doing
weird in
all
this
of the
project.
work in responding to those USB descriptor requests. There's a 16-bit address space.
I don't want to use a
directly
leaked
to the
copy of
8051
IDA.
processor,
I try to
a
use
bus
legit
which, among
software
other things,
here.
happens to have the USB controller.
But
on
yes,
it.
I understand.
The ARM processor has access to that same bus, but via kind of
I
this
think I had
intermediation
Tuco
layer,
scratches
this
done
protocol
on my
where you
hand.
kind of ask for access, do a handshake. Like the bus kind of belongs to the
Do a
8051.
handshake.
The ARM has the ability to kind of like ask nicely and get access to it. The ARM processor initially uses that bus to install firmware on the 8051, but then you can actually see it using that bus both to communicate with the 8051 firmware and kind of pass messages, and to just talk to the USB controller directly. The ARM processor seems to directly
This
get
part is pretty
interrupts
weird.
for the USB controller. So this is actually really encouraging and also really baffling. It means that the custom firmware I write for this chip could actually be a lot simpler than I thought. Like, maybe I don't even need to write 8051 firmware, maybe I can just turn off the 8051. There's probably a good reason they have the 8051, and I'll probably discover that later. I have some hunches. Timing sensitive operations, to still be able to respond back to the computer even when the ARM processor is very busy. Maybe it's just vestigial. Maybe it used to be a separate component. It's really hard to tell at this point. I started to map out the 8051 register space. There's some stuff down here that seems to be SCSI, or seems to be other things that are used for communications between the ARM and the 8051. In trying to map out the memory for the 8051, I ended up using kind of a different process than I did for the ARM. The 8051 just has so little memory. The CPU itself, I think, has 128 bytes of RAM, and then I found another.
The reason this seems so fast-paced is because it's edited together really frenetically. It was not
more of an issue
necessarily
of
this
editing
fast-paced
text
when I was
files
actually
and
describing
doing
it for
things
the
by
camera.
hand, because the scale of everything is just so small. When I did this on the ARM, there was just so much more going on. I needed a better way of visualizing that. This XKCD was actually really inspiring. He's come up with a way of mapping out all of the IPv4
I
addresses
guess
in the
people are
internet by
into
taking
that hair, huh?
giant 32-bit
In
address
a good way or a
space
bad way.
and folding it into a space-filling curve that fits into a square, and he chose a Hilbert curve. And the cool thing about this is, you know, even though you lose the property that
Yeah, I
it kinda
used to
reads
do a
off
bunch of
the
weird
top
stuff with my
bottom.
hair.
Now
I
you
used
have
to
this
dye it
property that
purple
things that
for a
are
long
nearby
time. There's like
in
solid
the address
purple.
space are nearby in the image.
I still
So
have
this
a bunch of
is
that purple hair dye.
what
I
I've
thought
called
about
a
whether I would ever
memsquare
use it again.
for all of the address space on the ARM processor. This region down here is DRAM.
Yeah,
This is
should I
the
be more
entire
polygonal next
32-bit
time?
address space on the ARM, going all the way
Referencing
from
the
0
Max Headroom
to
comment.
FFFFFF. Since this is surveying all the address space, it's pretty coarse resolution. Each pixel here is 256 bytes. This whole square here is 64
I have one of these
megabytes.
that's
Different
yeah,
information
the one
is
on the
mapped
table
into each
there
color
that's
channel.
all
Red
soldered to
has
oscilloscope probes.
The average value of
in a
each
box
block.
somewhere. I need to
Green
find
has
it.
the variance.
I've got
Taken
a
together,
fully
they give you
assembled
a lot
one at
more
least.
Information about the composition of these memory blocks than either individual plane. The blue channel is a logarithmically scaled representation of the memory access time. This is a higher resolution memsquare.
Yeah, I feel like when I had that haircut, I was a bit of a scenester, and
this kind
I
of
try not
weird
to be these
square
days.
pattern is what happens when you have uninitialized DRAM. This kind of like static pattern. The static is a little bit different depending on kind of how much electrical noise was in that part of the chip. The physical distribution of those charges don't really map directly.
What a
to
weird
the
color
addresses.
scheme too.
So these kind of tell
I
you
think
how
the
much
lighting in
information
that room
you
was
get.
just kind of
Average
weird,
value
and
of all
so
blocks
the color grading I
and
did on the
variance, like
edit
how much those are changing.
made it look pretty
And
weird
then
too.
access times for all the regions here that are mapped. And the mapping region is a little bit weird.
I was
you can
like-
see that it isn't quite.
I was
mapped
still
on
pretty
even
new at
boundaries.
Max or at
And this is actually
Final
correct.
Cut
Like, it's-
Pro
this is-
X
there's like
at
a
the time.
32K chunk that it's kind
Now
of
I'm doing
offset
everything
by.
in Premiere.
It's a little bit weird. So I think that's all I'm going to say about memsquare. Right now I'm connected to this over USB using the kind of backdoor commands that I patched into the firmware. So I've added a new
Yeah,
command
man,
line option to this bitbang command.
That haircut
installs
was
an
just like a
additional
totally different
debug
world
stub
for me.
the 8051
Like-
processor. So here it's already switched to the bitbang interface. Now it's sending a little package of data. That package contains the 8051 firmware itself and a small library of ARM functions that I can call. The 8051 and the ARM can just use this one little byte of shared memory to kind of send data back and forth. And then just like I did over the serial port, I have a little debug stub that just sits there waiting for commands. I can do things like read 8051 memory. And this is an example of some of the 8051's memory mapped I/O space. LOC is
Was I just getting into the 8051 for completeness, or was there something specific I thought was there?
This line is actually the last SCSI packet that the 8051 processed before I reset it. The firmware is really small. It's just this one C function. It uses just a couple of the registers that I found on the 8051.
I'm like spacing out and not even paying attention to this architecture that past me is describing here.
Communications like this. You know,
but yeah, like it sounds like a command queue.
Area. This is just some unmapped memory. This 8000
we'll have to
area appears
dig
to be
back
some
into
RAM.
what this is actually
When
doing.
I started trying to figure out how the ARM and the 8051 talk to each other, I would start to find these repeating patterns in the register accesses in the simulator. You could just wait for it and kind of let it go. If you can replace the very repetitive operations with something higher level and more concise, this helps a lot with understanding.
Wow,
So
I should
when
have
I
written a
found something
SIGROC
that either
decoder.
I understood or that I wanted to figure out how to generalize, kind of try to wrap it up into a little C function, kind of hack on separately. And then once I had a C function that worked, I could add logging to it.
Oh man, Tuco hasn't had that color in ages.
So the shared memory bus with the 8051
Is that the
has
one
these
he
accessor
lost
routines,
when we
and it helped
moved
a lot
here?
to use these high-level emulation hooks to replace the simulated accessor routines with C++ accessors. With the benefit of all this higher-level tracing output, it becomes much clearer what the 8051 registers do and how they're being used for communications. Okay, so the 8051. I know enough about the 8051 to know that I can put it aside for a little while. The first thing the simulator hit that I
That's what
couldn't
we were
run
getting to.
was this encrypted function.
Oh.
So in order to get the
Do we really want to go into the simulation approach? I guess that probably is still a decent tactic.
Doing that kind of thing. I hit these three kind of big distractions or challenges along the way. The first thing that got in the way was actually an encrypted function very near the beginning of the firmware image, address 11,000 hex. And they start out with this very suspicious looking sequence. There's one instruction up here, this MSR. In this case, this instruction is actually ensuring that the processor has interrupts disabled and that it's in supervisor mode. You know, if either of those conditions weren't true before this instruction runs, you're guaranteed that it's true after. And then there's a bunch of no-ops that just does nothing. I can think of some reasons why this might be necessary. It wasn't really completely clear that it was an encrypted function, but there were some giveaways. By context in simulation, I can see that this function is being called, and it starts with some code that is valid, but kind of weird. Then it just continues on into some stuff.
I've still got the same power supply, but it's got a busted segment on the display now.
There's actually a region where every 16 bytes actually repeats. So this is actually a giveaway
Electronic
that
coloring
using a
book
particular
mode.
kind of encryption called ECB mode, or electronic code book. Every 16 bytes of code, every 128 bits, like a word in a code language, then you would take that word and look it up in a dictionary and find another word
from
substitute
POC or
in,
GTFO,
usually
the
in
electronic
practical
coloring book.
to figure out the entire dictionary. Because you know that that substitution always happens the same way, this kind of encryption is actually pretty bad because it gives away a lot of information about your data that you don't really need to give away.
Yeah, so I mean,
It's really
Station
fast,
240 is
even
getting
if
to
you
the
have
active
random
question
access.
here. Is like,
I
well,
would
what does the
expect that this
8051 do?
encryption
So like, the
happens
thing I was
every
just
time
describing was a bunch of
line of
experiments
16
to try to
bytes
figure that
is
out.
fetched out of
I
memory
think
into
the
the
end
processor's
result is
cache.
that
And
we
this
don't really
section
know,
at the
but
bottom
probably not
probably had a
much.
padding byte to indicate that this section of memory isn't used.
But it does seem like it processes the SCSI commands in some capacity, which is interesting.
So
I don't know
just
why
by
it would
seeing
be.
that the encrypted values are the same, you can tell that the unencrypted
Because yeah, I think my
values are the
assumption would be
same.
that maybe the
And so you
8051
can
did
tell
the
not only
SCSI
what
/
kind
SATA
of encryption you're
interface,
using,
and the
but
ARM would
roughly
do
how
the
big
drive
encrypted
control,
function is,
or
just by
vice
looking at
versa.
the encrypted code.
But yeah, it seems like
Depending
most
on
of it's on the
operation,
ARM,
they
which is
actually
weird.
invoke one of three different encrypted functions. The one on the right is 11,000, the one that I needed to figure out because it happens very soon after boot. Here, it's putting some pointers into memory-mapped I/O registers. Then after programming those memory addresses into the hardware, it just jumps into the function, just like it would normally make a function call. After making that call, the processor enters this sequence where we make sure we're in supervisor mode, and then there's this weird sequence of no-ops. It's actually programming pointers into those memory-mapped I/O registers, specifically demarcating this region of memory, just the encrypted part of the function. Yeah. So it's telling the hardware, you know, when you get to this point in memory, think about decrypting it. This is actually something you see a lot in video game consoles or in other hardware where they're intentionally trying to protect it from some kind of tampering. In the case with video game hardware, the whole system is just oozing with DRM.
I don't know where we'd all be without 2x speed video.
Without paying them licensing
Yeah, I
fees.
really like fast video.
And now there's this encrypted function. So I figured this might have to do with preserving a chain of trust, some way that, you know, later on after the system is booted up, some piece of code probably related to DRM, you know, Blu-ray video decryption, you know, probably some of that nonsense. I would expect
these folks probably had a head start on implementing like trusted boot because they had DRM requirements.
That would be necessary in order to have the hardware transparently decrypt.
I mean, chain of trust in general is a great idea.
Like figuring out how to set up the crypto hardware.
It's like really hard to trust firmware right now. Like you need hardware that can audit the firmware, and you need like a standard way of like doing that.
Look inside enough to figure out whether
seems pretty unsolved right now.
Or not. I took some notes on some of the experiments I did to try to figure out the cryptography. Right now it looks just like we had it.
Yeah, so the NOPs,
I wrote
like
a C++ function that only knows how to do that one.
I think self-modifying in this case is kind of the deal, except
it runs and then just returns value. And
so like the question, couldn't that no-op field be something like a self-modifying code? So I mean, to me it says either you're waiting for the like something to get pushed out of the cache, or you're trying to pad the code to end up so that it starts at a very specific boundary, maybe some combination of the two. And yeah, you would see stuff like that with self-modifying code if you were like running it out of RAM, modifying it, flushing the cache maybe. I don't think this runs out of RAM. I mean, I don't remember. I'm like looking at this project for the first time in 4 years, so like maybe it runs out of RAM, but I thought this all ran out of flash. And the reason behind this would be due to maybe turning on a hardware crypto unit, which then processes this region of memory. Hey, Tuco.
The important thing here isn't the value itself, because I have no idea what this is doing at this point, but it's just that it runs and it doesn't crash and it returns. This tells me that I can get in and then out. If I was just running the encrypted code as I see it in the simulator, it would
thanks for standing on the spacebar,
Tuco. The processor just hits these instructions that are apparently garbage. But this tells me that something really fishy is happening, and there's some kind of automatic decryption happening in the hardware. So I did some more experimenting with these registers. That initial sequence with the MSR instruction and all the no-ops, it looks like an unlock sequence. Like they have some special hardware unit that does cryptography, but in order to just make extra sure that it doesn't decrypt stuff by accident or decrypt stuff without being set up properly, or maybe it has to do with making sure that the instruction cache is clear, for whatever reason, they have some hardware in there that only enables the decryption if it sees this specific sequence of instructions.
Let's see, so James is asking how early in Blue we're talking.
Kind of unlock mechanism. Code is never really just instructions. Code
my memory on like what part of this I'm talking about right now was fuzzy. I think that I'm talking about the main application and not the bootloader. But
I found a way to exploit that to get these functions to read themselves. It turns out this was actually pretty easy. I've been using this hardware feature to patch flash memory for investigative purposes. I can write some code or a breakpoint instruction into this little piece of RAM and then move that piece of RAM anywhere I want and put it sort of over top of the flash memory. So I was curious how this interacted with their transparent decryption. There's got to be some kind of ordering. Either the decryption happens before or after that memory overlay. Turns out that the decryption happens first, and then the memory overlay happens afterwards. So if I do that overlay, I'm actually overlaying onto the plain text, onto the decrypted code, not onto the encrypted code. And, you know, either way, I could probably use this to get in. Like, if there's any kind of way I can modify that code using the overlay, I think I could use that to get into the system. But this is much easier, because now I can just take plain text, you know, unencrypted ARM instructions and just patch those in. And I don't know what...
Yeah, that would be a lot of pipeline. I mean, I'm thinking more like encryption block size alignment, or something like that.
I can at least read the rest of the code. I can write a patch into the very beginning.
This patch mechanism seems fun. I'd forgotten about that.
Loads an address, in this case this 11100, and then reads one word from that address.
Yeah, what was this? It was like some kind of memory segment controller.
To see if
you
we're
can
successfully
remap
reading
RAM blocks.
unencrypted code. First I'll just read that same address through the debugger. That whole area around 11100 looks like random garbage, and this first word shows up here. It's this 12BE, etc., and doesn't really seem to mean much.
Right, I'm trying to make sense of James's question, so there's enough time between asking the description bit to start and it actually starting. Are you talking about like how I can get code running in the first place? Because I think at this point I'm just modifying the firmware and changing the CRC, because the firmware is not signed. So, Like, this doesn't seem to be like a complete, like, trusted firmware implementation. It seems more like they're obfuscating individual functions. Does that answer your question?
It returns the word I'm interested in R0, which is the return value for a C++ function. Now when I run it, I get a
you're
value,
asking about the knobs.
which is different from what I saw in the unpatched function. It doesn't crash, and it also doesn't return the same value the debugger returns. This returns something that looks a lot less encrypted. You know, it has a lot of zeros in it. It's a smaller number, and it's unlikely that you'd see a number like this just kind of randomly in encrypted code. So this probe that I insert obscures 8 bytes of the original function. Aside from that limitation, I can now read out the entire plain text of this encrypted function. So this is a simple loop in Python. For every word of memory, it'll assemble a little program. Smallest way to just read one word of memory and then return. Just invokes the firmware's own function that runs these encrypted routines. And then it returns with that word we asked for. So this is a much better memory dump. This one starts with the no-ops and the MSR, and then it goes into ARM code. Alright, so here is the inside. These are some instructions that somebody was trying to keep secret. These instructions here are actually the probe that we were using to read data out. Start in the middle of the first thumb function because the very beginning was cut off. And we've got a substantial amount of code here. This isn't just sort of one routine. That subroutine was some kind of entry point to, you know, kind of a larger subsystem. This does have some code that talks to hardware. These addresses here, this 406 region, this is hardware. When I first started investigating this function at 11,000, I had no idea what it did. It seemed like this function might be part of setting up some kind of DSP interface. It might be part of how some of the hardware is initialized. So there we go. After I saw this, I knew I really didn't have to go any farther.
Yeah, it seems less like a pure delay and more like
access content system, I think. The DRM system they use for content protection
DRM obfuscation
on some Blu-ray discs. DRM, you know, it never works. You give people a disc and you want them to be able to play it. But
yeah, I mean, maybe with the no-ops, again, like that could be something where you're...
And eventually people are going to figure it out.
Where you're like trying to push an entire chunk of data through the whole pipeline somehow. And maybe the pipeline in this case is not the CPU pipeline, but like a block-oriented crypto pipeline.
Parts that I actually need to run the system, so that I don't have to reverse engineer the DRM, because neither of us really want that. I think what's going on is that this is some sort of boot up initialization for a library that handles this AACS decryption. I've tried just stubbing this out, replacing that entire encrypted function with something that just returns 0. So far that seems to work. Problem number 1 worked around. I don't have to deal with these encrypted functions, I can just stub them out, and it seems like they're only for DRM. Then I also originally thought there was another kind of DSP block over here.
Oh my god, uBlock Origin has blocked like 380 things on my YouTube chat laptop over here.
Now I'm letting this thing run,
Thanks,
but I'm
Google.
also trying to figure out what it's doing. I was under the assumption that this function was related to installing DSP firmware. It took 2 parameters, and the first one was a pointer to this region of code, which I couldn't really make sense of from the hex dump, but it looked like it might be instructions.
I don't think we know what architecture the DSP is at all.
There are actually a couple of these.
I think there was maybe some hints,
as kind of DSP firmware before. That's kind of all that made sense at the time. This thing has a slow ARM processor, 2 MIPS executing code from DRAM. I expected that they would have another CPU, probably a DSP core, that would actually handle the kind of data encoding and decoding and all of that. They had different firmwares for different kinds of disks.
I'm kind of expecting the DSP core is pretty necessary in order to do anything useful with the laser, but that we could control a lot of the motors without using the DSP.
Because the DSP would need direct access to it, and that I would really need to get inside the DSP via this firmware upload. So
I'm guessing there's like some motor control ASICs.
As input.
The DSP has probably got some kind of FIFO that processes data from and to the laser. There might be also some separate buffer that the DSP can access that drives the voice coils that do the focusing.
On the fly to talk to the DSP, maybe it was like a library. That seemed kind of far-fetched. It seemed a lot more likely.
I'd expect there to be like a ring buffer full of focusing data that goes out to the focusing motors.
So they take all of the stuff that they can get away with swapping out, the disk type specific stuff maybe, put that into this compressed little package. The decompression still takes a couple of seconds.
Compressed
even
little package.
But you don't usually notice this because I think they do it while the disk is spinning up. This is the actual firmware decompression.
That's right.
function.
They were detecting the disk type,
and I haven't bothered
while the disk is spinning, and like while the disk was spinning, it loads this overlay that's kind of actually slow to decompress.
The inputs and outputs.
So that is running out of RAM then. That's interesting.
And these are 2 output paths. Likely one of them goes through like a dictionary table, and one of them is through for literals.
I forget what the
It's
boot
reading some
path
data
is like. Is
tables
this
from
the
beginning
like
of the
on die
compressed
ROM plus
firmware,
external SPI
presumably
maybe?
to initialize a decompression state machine. Maybe these are like Huffman tables or frequency tables, that kind of thing. Up here, this little blue region. So blue on this diagram is code. Brownish stuff is like kind of uninitialized or kind of undeclared data. Down here, this is flash memory.
Tuco was just so napping that day that I recorded
this. There's a lot of code here, and it's doing a bunch of things. I was really surprised to find these. So inside the decompressed firmware, these are actually double precision floating point constants.
Right.
In this C code that's running on a pretty slow 32-bit no floating point processor, these have got to be parameters for a DSP. No, they've got a software floating point library, FP double multiply.
That was a big red herring.
I
thought for sure that was something DSP related.
It must not be at all important how fast this stuff goes, or this ARM processor has a way of running way faster than I think it can go. And no, I don't think there's actually a DSP at all. There might just be little hardware modules sort of all over the place. Motor control. And lasers. Everybody likes lasers.
Yeah, I'd forgotten about that twist.
Simulation
That's interesting.
from like a saved state. The compressed firmware takes like
I don't know what the ASIC would look like though. But it might just be a bunch of decode blocks that handle the specific protocols they're looking at.
A way to save and restore state, so that's what I did. I'm just going to reset the simulator. It's sending a block of high-level emulation routines, and these are so that I can say, at this point in the code, I want to replace that with a chunk of C++ code. And
yeah, so I was running the firmware locally on a PC,
kind of try to
sending all the I/O
low-level
off the drive
with higher
to
and higher
debug
level bits of my
the
own
interface
code
between
as
the
I
processor
go
and the rest of the drive
so
hardware.
high-level emulation stubs are installed, and so now I could single step. I'm just going to run continuously. I found some functions that crash because they expected the clock to advance at a particular rate, and so I tried patching those in various ways. This firmware decompression is really slow. Now that the USB controller is initialized, the computer is kind of trying to talk to it, trying to say, hi, I see there's a device there, what are you? The device just isn't listening or isn't responding fast enough. It's over 36 million clock cycles later, and we've reached the main loop. So I sort of jury-rigged their main loop and interrupt handlers into kind of a round-robin main loop, so that it kind of polls all the hardware to see if anything needs to be done. You should be able to see it interacting with some of the hardware.
Yeah, this is interesting. I'd forgotten that I built this whole emulation framework.
I have it generating these commands just ready to be pasted right into the shell when it writes to hardware registers. And so now it's interacting a lot with these registers in this 4206 space, which I'm pretty sure is the stepper motor controller, possibly a more generic motor controller. Time for plenty of coffee breaks while the simulator runs, but I have a feeling it's about to get exciting. And it does seem to write to these 4206 registers quite a lot before anything happens with the hardware. It's not like I can find a bit that's just like, one step. It's higher level than that. And it's not even like,
Yeah. So it's like preloading the motor controller with some chunk of data, and then it executes a command.
Stops making a terrible noise.
Interesting.
And then goes on with things. It's oftentimes actually hard to tell even if it's hung or not, just because the process is so slow. Even if the simulator was as fast as
what do I use to emulate the ARM instructions?
This is
Did I
basically a
write that
56K
myself?
modem that I'm doing all my I/O over. It's just kind of going into these sequences where you don't really see it doing much except kind of repetitively banging
so much
on this
code
one
that I've
register.
forgotten
You run
about.
the simulator, it either crashes or it'll just kind of keep running and you're not really sure if it's working or not. If you got everything right, if the ARM simulator was flawless, and if you aren't going to hit any kind of, hidden gotchas in the hardware, maybe you come back, that afternoon, and you've got some output that you can make sense of. I think the next thing it would do is to try to, move the lenses and focus them, but I haven't actually seen it turn on the laser in this mode yet. Things never go perfectly the first time, and so I think a lot of what this has been is kind of learning how to fail quickly. Right now I've just kind of opened up this whole new thing. I've got this simulator that's finally working well enough to talk to the real hardware, and I've seen, the hardware actually move and interact. Now there's just like a wealth of things to work on and things to open up, so it's really exciting now. This is a really, really cool time in the project. Feels like I'm kind of getting past all those barriers. I have high-level tools that operate on that code, which has direct hardware access. So now I can, make a lot of progress quickly, hopefully, and really get a sense for what all these registers do. It's at the point where the hardware is pretty well initialized, and the motor controller is turned on. Oh, kitty, you're back. What's up? So here I've got a file
too real in
with
these
a bunch of
headphones.
the register writes extracted from that simulation log. And if I just copy and paste these into the shell here, then a whole bunch of things happen. The motor moves one way, and then it moves the other way. I kind of continued to cut that down to just try to figure out what registers actually made the thing move. Kind of a minimal sequence of these 5 register writes that just kind of moves it a little bit. And I can just repeatedly issue those as many as I want. And I can kind of move the head back. If this was kind of a typical stepper controller, like you might find
Where specifically did I have that serial port
you'd have like a
attached?
step pin, you'd have a direction pin, you'd write
think
code
I
that
documented
kind of
that.
times out your steps and kind of toggles the step pin, and I don't see any of that. It just moved. That was like almost a centimeter. This is a really high resolution stepper motor, so that was a bunch of steps. I don't really see anything in here that even seems to indicate like a number of steps. So I think what I'm actually just telling this to do is to take the last motor movement that it was programmed to do and just execute that again. There's going to be a lot more work in
There
terms
might
of
be
figuring out what
pointers
all
to
these
motor data in
registers
a
do
buffer somewhere in
and
memory.
mapping out, how do I program the motor controller to make a particular motion? Because I think that's the kind of level of control we're dealing with. But at this point, I can at least kind of, do these replays and take stuff that I've seen the firmware do.
Oh
and
man,
kind of
I
do it
worked
again.
really hard on
And that
this
gives me a
at the
sense
time.
of what the registers do.
I remember
and
just
I can make a lot more sense out of these giant log files this way. So at this point, I'm inside the
I
arm.
buried myself in it
I'm
for a
inside
few
the
weeks
51.
and had this unnatural
Inside
amount of
the flash
energy at the
memory.
time.
I know kind of where to start with the USB controller. There's a lot that I can reverse engineer now. Thanks for watching, everybody. See you next time. All this code's in GitHub, so you can get your own
There we
drive
go.
and hack along.
Here's the bottom of the drive. Yeah, oh man, what a whirlwind. Like that was probably actually like some kind of manic episode that resulted in these videos, but they exist now, and maybe we can try to follow up on it. So here's the code. Yeah, MT1939. So that's right, we have a binary patched version of the official firmware where we place a little patch in one of the SCSI callbacks, and then we can use that as a jumping off point to do more things. That's generated by this tool that modifies the firmware. So these are the commands we have in the debugger shell. You can read or write memory. You can do this like ORing stuff with memory and clearing and setting bits or whatever. You can assemble an assembly here. I think this just calls out to an assembler on the shell. Same with C++ code. It just uses GCC to compile a tiny binary. Then it has some way of proxying the standard out back, which is interesting. I forget how I did that. Code tracing, global variables, SCSI scripting. Yeah, that looks fun. Did I not document the ARM emulator here? Or is that what hook is for? How does this all work? Let's see libraries. Oh, this is the local Python module written in C, which talks to the device over, I guess, a SCSI library, tiny SCSI. So yeah, I thought we might need USB level communication with the device, but it seems like everything interesting is a SCSI command so far, so that's the level I've been hooking it at. So a Python SCSI library, so we can send low-level SCSI commands. And then a bunch of Python stuff. Simulator. Oh, SHA hexsums, or SHA sums of the firmware. Cool. That's pretty cool. Run a snippet of assembly code on the 8051. This is behind one of those commands we had in the IPython shell. This is the code it's compiling with SDCC, which is not a great compiler, but it's a little better than nothing. Simulator ARM core. Oh gosh. What have I done? Yeah, so this is just some Python code that like runs an ARM disassembly. I wonder if there's a better way to do this now. Wow, so I wrote 1,400 lines of Python code to do this for some reason. I imagine that I looked for a better alternative and couldn't find one. Yeah, it looks like I can patch parts of the emulation with kind of high-level emulation functions that take over some of the work, which is nice. Memory map. So yeah, here's where we're defining some stuff that currently doesn't really have anything backing it, but we kind of know what it is, maybe. Oh, interesting. So I think I'm ignoring the boot process as much as I can and just trying to deal with the main loop. That's what that's for. Whoa. Yeah. Yeah, how does this patching actually work? Oh, this is the patch that we apply to the firmware. Yeah, so this is a new definition for an obscure SCSI command to get performance data. Man, 2014. Eject, yeah, that's cool. Oh man, well, it'd be interesting just to see if we can get the shell running here, although I do want to actually fix Tuco Flyer. It might be a good time to switch tasks here. Let's just see how easily we could just compile what we've got here and poke around a little bit. So we need a compiler for the local machine and ARM and 8051. We've got something claiming to be GCC, which is actually going to be a LLVM. We've got, we've already got that installed, ARM on the API GCC, which is an ARM toolchain that targets ARM without an operating system. And do we have SDCC? We do. I don't know if that's a recent version, but sure. We have IPython. You usually want to have no disk in the drive. There was a drive I was trying to keep pretty stock. I'm hoping it's not this one, because I might reflash the firmware on this one. Let's see if we can compile this. Oh, so this is just going to try to download the firmware. Oh, did that fail? Yeah, I wonder if the firmware is not still available. Now they're advertising DVD writers. That's interesting. Do they not even make Blu-ray stuff anymore? Let me search for the model then. What was that? SE506. I think their website's just broken. We could just download it from a random website, which isn't actually that big a deal because we're not going to run this exe file. We're going to unzip it. And I have a SHA sum of the firmware. Is this going to be nothing but malware? We have a file. Okay, it just wants that in bin. And that's a 0-byte file from the failed download earlier. Okay. It looks like it, let's see what it just told us here. So we unzipped it, copied the firmware, inserted the patch using DD. And then flashed it, or sorry, we used the flasher tool to fix the checksum. And so this is telling us, warning, this tool intentionally bypasses the integrity checks, meaning it's easy to brick your drive. Yeah. And then we're building the Python remote stuff. Oh, does this maybe not work on macOS? Do we just need... I mean, that's not related to this problem. I'm just realizing that I think I made it work on macOS. Let's figure out why we're getting this path issue. Really? Why would it not have standard arg in its path? That's strange. Let's see if anybody has a solution for this, given the homebrew environment here. I don't know why this would be missing the standard library headers. Okay, cool. James mentions that there's a diagram in POC or GTFO7 that shows where the serial port is on this chip. I don't know if I want to be using homebrew Python. Probably, though. I think I already am, and it's just not installed correctly. Wow, so slow. How's the self-hosted live stream doing? For anyone who doesn't know, you can also tune in at live.diode.zone/scanlime. How's the self-hosted live stream doing? Seems alright. So I can see what the bandwidth is like. It's actually busy encoding some video right now. We can just look at the last hour. A little bit of video going out, not a ton. There was a lot of folks were watching on the self-hosted stream last time. Do we need to try a different mirror here? I should really have my own POC or GTFO public mirror. I've certainly just hackishly mirrored individual episodes or individual issues by copying them onto a server that I have, but I don't have a good collection of them somewhere, which seems like a useful thing to have. Yeah, so I wrote an article about this ages ago now for POC or GTFO, getting inside your optical drive's head, art hacking, laser robots, etc. So this actually might be a much more concise kind of write-up on what I've done so far than watching the videos, although the videos are an interesting ride also. the shell, code patching. There we go. Serial out, serial in. I was grabbing this off of a buffer chip here, it looks like. Oh, this T-Pick 1391 I think is a motor controller. Yeah, bit bang. So we can't really redo this without soldering wires to a new drive or finding the one that I've already soldered wires to, which is just requires a little bit more shop organization. And then there's the CPU emulator. Yeah, well, this certainly is a big project. Yeah, it seems like the next thing to do probably is to find the drive that I've already modified, but I'm also just kind of curious, like, if we can just like at least get the tools built. But I might shave these yaks later, since this might just be like a Python build tool chain issue going on. So anyway, this might be a good time. James likes how the self-hosted one does not switch resolutions automatically. That is a feature I would like, though. That is kind of a lacking feature in the client. There's, as far as I know, no open source video streaming client that can do like HLS or Dash or whatever, which will automatically switch resolutions according to the bandwidth that's available, which that would be nice. Anyway, let's put this aside for a sec, and it'll be a thing we can come back to in a future stream. And I'm gonna switch gears to this thing that's behind me that is in need of a DC-DC converter, some screws, and maybe some LED wiring. So let's go back to this camera. Oh, Tuco's on the chair right behind me. So last time we were working on this, I thought I was going to have to design like a 3D printed mounting bracket to hold this DC-DC converter. I think I can just zip tie it to the carbon fiber rods at this point, though. I think that might actually work. That's a good view. Yeah, so this is a bit of a tight fit maybe, but something like that. One limitation is that this board here where my thumb is, that's like a radio antenna. It's a motion detector. So it's not the most critical thing, but if we can keep some space in front of it, that would be nice. Oh, you know what? I think I was mistaken about how this went together. I think I lied. I told you that the LEDs slide off of the center core, and then that core is bolted down. I think the LEDs are glued to that core, maybe? We might have to deal with that if they are, but I think maybe the first step is to take this whole assembly off of the bottom plate. What did I do? Oh, that's cool. There's a comment that a player called Clapper, which I haven't heard of, supports switching quality and resolution. That's great. What do you know what protocols it supports? Like, does it do HLS or Dash or something else? Oh, and also what operating systems? Because I think my ideal solution would support, you know, like all the common OSs and mobile platforms and whatever. And I don't really care that much about what the server is, because I could set up whatever server that client works. But I think primarily I want something that has good OS support. It seems like HLS is at a point where you can find support for it on all the OSs. But yeah, I mean, I'm not really that attached to HLS if a different option makes more sense. Okay, I put this tape here just as a safety so it wouldn't slide off, but I think it's in the way now. There are these three kind of awkward screws. I'm really trying to be gentle with the camera. I don't know if I can get that elbow out of the way. So the gimbal is still attached to this bottom 3D printed layer, and that's the piece that's supposed to be attached to the carbon fiber, but currently isn't. And then the screws that I'm taking off should let me get the cylindrical part above this off of the base. I think these are like M3 by 20. And a couple of these feel like when I glued the nuts into their captive locations that I might have ended up gluing the bolt a little bit also. I'm hoping that the nuts are glued more than the bolt is. This is kind of slow going, these particular screws. I'm gonna find this long, like, spiral extruded bit of glue in the screw threads afterwards. Okay, that's... oh, the screw threads look pretty clean. That was 2 of 3. I've got They Might Be Giant songs stuck in my head lately. They released some new stuff, and it's pretty good. And then it also kind of prompted me to remember how much I like a lot of their older stuff. This screw is really sticky, and I'm trying to apply enough force to get it out without damaging the camera that it's right next to. I'm trying not to drop it too much. Oh, almost there. Oh, now this goes back in the clamp. Oh, that's cool. Apparently Clapper supports all the protocols. Does it really do RTMP in the browser? We are talking about something that runs in the browser, right? Yeah, let's take a look at that in just a sec. Okay, so it's free, there's just wires all over the place. I need to figure out what to do with the wires. I might just need to start cutting zip ties first. If I enable the software power switch, these wires just have 24 volts hanging out, which we could put onto the screw terminals. Yeah, there's this line in one of their songs, Don't Let's Start, that goes, everyone dies frustrated and sad, and that's beautiful. And that really has always been one of my favorite lines of theirs. It just seems like, I don't know, maybe something good to make peace with. Very perilous here. So now I've got a couple of pieces that are not really connected to each other. And the top of this is still connected to all the winches. So this is just kind of suspended from the ceiling. Oh, it uses flash for RTMP. That would make sense. Okay. So that doesn't really count. I assume that there's a non-Flash implementation of the other protocols, because I certainly would not want something that requires Flash. Flash is dead to me, and it should be dead to you too. I'm sorry to those people who like using Flash for animation, but like, yeah, it should be dead as a distribution format, at least. Maybe as a creative format, it might be useful still. Okay, so I think these are clipped. Oh, these are the power outputs. Gotcha. So these wires go to DC-DC converters that are in this bracket. This is something we designed earlier that has room for 4 separate DC-DC converters. So I think there are 4 5-volt outputs and 1 12-volt output, at least. Yeah, and then the 12-volt goes to the gimbal, which sends it to the gimbal motors, the camera, and some internal DC-DC converters. Okay, and these wires mostly go into the LEDs. All these little silicone wires are for the LEDs. I might just unplug all the power wires, because those are easy to unplug and easy to put back later. They're all color-coded. So I'm unplugging all these. Okay, and then this is data for all the LEDs. Okay, this is data out and power. What direction is this? Oh, I think this is data in and power out. This is connecting the top LEDs and the bottom LEDs. So I think the way the LED data string goes, it's a single string of APA 102 SPI attached LEDs. And the data comes out of the microcontroller along this cable. This is just power, or sorry, this is not power. This is ground, clock, and data, so 3 wires. Kind of off the top of the frame, it'll go to the top ring where there's a bunch of LEDs on the very top of the bot. Then that comes back down and goes to these 3 LED rings starting from the top. So one difference between the rings is I think they are in different power circuits. This could theoretically be a power, like maybe there's a problem with one of the DC-DC converters. One of the grounds. Simplest explanation, though, is it's just a break in the data wire, or possibly a dead LED between the first ring and the second and third. So let's just take it apart some more, try to get it to that point. Just unplugging some of these wires. That goes to the top. This, these are the gimbal wires, I think I've got to undo some of the Kapton tape up here to get the gimbal wires out. Dullest tool to cut this Kapton tape, and it just sits on the tape without cutting. There we go. That's funny, like, kind of people I would have gone to a They Might Be Giants concert with. Like, I think one person I did actually go to a Team BG concert with is, like, I guess maybe one of my oldest friends of this person, like one of the people that I've, you know, been in contact with for the longest number of contiguous years. Not that we've been really close, but like we were friends in high school, and like we still keep in touch online occasionally and are on good terms. And that kind of thing just seems super rare, especially as you get older. And I'm still not that old. I'm in my 30s, but it still seems super rare to have people that I want anything to do with from that far in the past. Alright, so this is still just kind of wobbling around in there. That's an LED wire that we don't need to disconnect. This is a gimbal wire that I would like to disconnect, and it's labeled. Oh, come on, gimbal wire. These are all those JST SM connectors from Adafruit. They're like pre-made wiring harnesses with the JST SM. What else do we have? There's a video cable, which I might disconnect next. So there's an SMA and a BNC up here. The BNC goes up to the ceiling, and then this SMA adapter actually goes to the gimbal itself. And that little adapter just holds them together. Alright. I think the top and the bottom of this robot might be separable. Oh, what is this wire? I think that's power for the microcontroller. That's power going up. That's also power going up, I think, for the LEDs? No. For the IR sensors. One of these goes to the... There's a bunch of lasers on top of this robot that are a little bit power hungry. Okay, and those are more power harnesses for the LEDs. This is an LED data wire tangled around the power wires. Okay, so those are now disconnected. So I think we can separate them a little bit now. The robot is a little lighter than usual. It's easy to see the center of gravity, I guess. It's a little hard to tell, actually, because of the angle this is hanging at, but yeah. Like some kind of Borg movie or something. Alright, let's see what we got left. Whoa, what did I do? Hope I didn't completely corrupt my file system there. Maybe we should switch cards just to be sure. I think my camera momentarily lost power as I was moving it. Let's switch cards just in case. This is spam disguised as a warning in the YouTube chat. Wow, card full. That's what you think. Oh, what a good cat. We could just watch Tuco all night, right? Alright, so we have this extremely tiny, like, spaghetti cable thing, which is holding the video. It's a 0.7 millimeter diameter coax, which normally you would use to send Wi-Fi through the hinge on a laptop. And in this case, it's sending the video through all the joints on this gimbal. And then this big cable has serial data for the gimbal. This is just ground. I thought it was just ground and receive and transmit, although there are 4 wires here. I'd have to look at my notes to remember why there are 4 wires. Oh, that's right. It's ground, serial receive and transmit, and it has 1 data pin, which is a pulse width modulation signal coming from the LiDAR sensor on the camera, or next to the camera on the gimbal. So this is data going back to the microcontroller. The yellow one is 12 volt power in, and then this is video. And then this is all LEDs. This is a booger of glue right here. It's not actually helping. I think I just dripped glue down in here as I was assembling it at one point, so there's some remnants because I haven't actually seen it from this angle before. Yeah, so this is glued together at the moment. So we have nuts glued in at these 3 locations that hold this onto the next layer. Stacked spacers and LED rings. So each LED ring has a top and bottom portion, like a ridge that holds the LED strip in a circle, and then those 2 pieces fit together. And then all of these 3 identical pieces, plus the bottom piece, which is different, those all stacked together. The bottom and this inner piece are actually the same printed part. So this printed with my hand would be like where the print bed was, and it prints kind of upside down as you're looking at it now. So all of this would have been support material, just like under these 2 bridges, and this circle here. Easier to point when I look at the thing instead of the monitor. Anyway, it's a little hard to visualize, but there wasn't that much support material. It was just under those areas that you can see kind of rough there. And then the full circle actually was a separate print that stacks on top. So yeah, we need to debug this separately probably. And that's the platform it was sitting on with the gimbal. A couple of kind of half-hearted heat sinks there. I mean, because this is not in a quadcopter, it doesn't have as much air cooling. And the motor drivers and the motors themselves are underneath these aluminum plates, which act as pretty good heat spreaders, so I just ended up sticking heat sinks on there. That looks like a USB micro connector. It is physically a USB micro, but electrically it's actually just TTL serial, which is kind of weird. It's like 3.3 volt level serial. So that's the same signal that comes out on the blue and white wire over here. Those are receive and transmit. Those are also the same I/O pin used for pitch and yaw signals, like as you normally send from like an RC aircraft receiver. Those you can kind of switch the processor into a mode where they're used as a serial port by responding to a packet that it sends out right after power on. But in this case, we modified the firmware so that it's always in serial mode, because I don't want to have that entire protocol stack up to respond every time you power on the gimbal, and I didn't want to have to power cycle the gimbal just to get it back into that mode. All right, well. to help this come down a little bit. This is still very bad at balancing the tensions at all. Like, it isn't really trying. Like, the tension algorithm is still something that's kind of TBD, and like working on it without a great tension algorithm is annoying. So yeah, I was thinking this could basically just go right on there with zip ties. I was trying to keep the area immediately on the outside edge of these rods clear for the entire height of the robot, to facilitate putting a wrap around the whole robot, just like a single cylinder that would cover the whole thing. And this will get in the way of that a little bit. So I might have to rethink this when it actually comes time to make a covering for the robot later. But for now, I'm not worried about it too much. So I just need a couple of zip ties. Be right back. Welcome to zip tie land. So yeah, I think I want to put this in from the back. Through there. It's relatively flat, but yeah, it's not perfect. And I want to try to get it as far below this motion sensor antenna as possible. Motion sensor antenna is not extremely important. It's just kind of an add-on. Like, if it works, that's great, but if it doesn't, it's not critical. Oh, there's a little bit of Kapton tape holding this DNC connector on. I need to slice that without hurting the carbon fiber rod. Yeah, I would love to know more about open source players that support resolution switching as well as live streaming and video on demand. I mean, so some of you may know, if you've been tuning into the recent streams or following me on Twitter, that I've been kind of getting interested in like decentralized web technologies. Is that my phone buzzing? It is. Yeah, as I've been interested in like decentralized web technologies, and running a PeerTube server has been part of that. And PeerTube is cool. I feel like it's still a pretty early project with a lot of rough edges, and there's a lot to be. I feel like there's a lot to be kind of on the fence about, like in terms of the design and the focus of the project and the community around it. So I've been kind of keeping one foot in and one foot out. It's like, I'm interested in PeerTube, I'm interested in running a server. I want that to be the start of a community that maybe has a potential to go, forward into the future sustainably somehow. But like, I also want to keep investigating other technological approaches, preferably things that are in some way compatible with PeerTube. So maybe a way to have kind of HLS streaming style video on the server, but still interoperate with PeerTube servers using ActivityPub. Because I would like to converge the whole live and video on demand streaming setup. It doesn't seem like those have to be different, and it seems like a service that can support really solid like streaming with replay can just use that same infrastructure for video on demand for the most part. So yeah, like the whole way that PeerTube is building, like torrents around single files as their kind of primary thing, and then everything else is secondary. Like that's not quite the technological strategy that I would take. And then the social strategy where, you know, like content aggregation is primary and like moderation is secondary also isn't quite what I would want. So, you know, like I'm happy it exists, and I'm going to try to work with them to the extent that, you know, it seems like we have compatible goals. But I'm also like looking out for alternatives. So, but yeah, I mean, that said, like I've got a bunch of video on this PeerTube instance. You know, I'm sharing it with anybody who wants an account from this community, basically. So if you are interested in the concept and you want to try it out, then just like DM me on like Mastodon or Twitter or like wherever else you find me, but mostly Mastodon and Twitter, I guess. And yeah, I've also got a Twitter account specifically for Diode Zone. So it's just at Diode Zone at Twitter. So yeah, I mean, if you have content on there, like, I mean, I want there to be a migration path, basically. So, you know, I don't want to, like, I've got this kind of archival mentality when it comes to stuff like this. I want a system where, like, it makes me cranky that PeerTube does not store the original videos before transcoding, because I would want there to be a lossless way of repeating the transcode even. So stuff like that annoys me. And I would want something like this to basically serve foremost as a federating index of videos, and to have that be the sort of durable functionality that it provides. And then, you know, the UI can be maybe something more experimental that has different phases it goes through. But ultimately, I would like there to be a durable way of providing like hosting for federated videos under a system like this. And for that to exist, like things that I'm concerned about really include like metadata and video format, because those are things that you kind of have to get right early. If you don't get the metadata right, people are going to have to retag stuff later. If you don't get the encoding right, you're going to have to re-encode stuff later, which is literally expensive. So, yeah. And so seeing like a video service, you know, kind of, I have like priorities where I want the stuff that has to be right from the get-go. Like I want that to have a lot of focus on it. And I'm concerned about what I see in that vein with PeerTube, but you know, maybe there's a way we can help it out. Or maybe there's just something different. I opened a bug in the GitHub to try to figure that out today. This was the result of a conversation in the PeerTube IRC that I had mostly with myself and with one of the other admins. But you know, I was just like realizing that, like personally, the thing that I would want to use as kind of a metric of whether I start with this code base and modify it, or whether I start with something completely different and just try to be protocol compatible, is that notion of how much is it going to support kind of segmented video, like stuff that is live streamed or stuff that is long and broken into segments at the protocol level. And so yeah, if there isn't a good solution for that, then maybe that's a reason to just start investigating something that is different but protocol compatible right away. So that's kind of something I'm trying to figure out personally. Maybe that also brings some focus into, you know, like I think there are a lot of people who like want something that is vaguely like PeerTube, but for one reason or another, PeerTube isn't exactly what they want. And it'd be nice to try to explore that space more and try to figure out like what other design decisions could be made in that space and what I might want to work on. This is actually quite sturdy. I think I might have tightened that a little too much. Yeah, let's just put that there for now. Certainly don't want to tighten those anymore. Alright, do we have enough slack? Oh, there is barely enough slack in this wire, so I'm going to attach this. This is spliced into the Ethernet cable that actually carries the power. I'm going to do less lazy and use a real wire stripper. Oh, when I moved everything around my shop, I seem to have lost track of my automatic wire stripper. I need to find that. There's like a little bit of soldered wire at the very end that I need to cut off. Yeah, I mean, I'm also feeling like, you know, I don't want to be like gatekeeping this experience. Like, I think it's kind of weird to like have to personally request an account for web services sometimes. But I'm also just kind of trying to make sure I don't get in over my head with the Diode Zone hosting, right? Because I don't really know how much space people are going to on average use. I also don't know how reliable from either like a content archival perspective or from just like a software or security perspective the PeerTube code is going to be, so I want to be a little conservative in that regard. But that said, I'm like totally happy to give out accounts, so I'm happy to do that if you DM me, but I'm just kind of, I guess, going through the reason why, like, well, why don't I just like completely open invitation? The main reason actually is that I've been hearing from other admins that there are already spam bots that can post on PeerTube instances. So, I mean, it's not that surprising because it's like free video hosting in a lot of cases, and there's no CAPTCHA or like verification system in the login yet. So we just have spam, and yeah, manual registrations are one way to work around that. Let's see, these screws are already open. Oh, I've got a hair cam. I can't see this and present it to the camera at the same time. I just need to open that a little more. Oh, I think I should actually even just pass this wire down the other side. So I have these little wire management clips. I think I actually want it to go down the other one. It's going to share a wire management clippy with the video cable. Is there even enough room? I'm like forcing it through there. That's not optimal. I don't have to use the cable management clippies, but I think that's an improvement. Or do we try on down here? This DC-DC is really overkill. It's rated for 60 watts, which is more than my input power supply is rated for. But the smaller one I had was overheating, or at least getting close enough that I had to add a heatsink. So this will be overkill. Let's try to put it there. And then this needs to go to the XT60 connector right there. So I think I need to make a new pigtail lead because this one is too short. I might just hold on to this as a separate object, I guess. So I need to get some spare ST60 connector and some wire. Okay. Whoa, am I just pushing channel selector buttons willy-nilly? Huh. James is wondering if there are lossless compression schemes for video along the lines of FLAC. I mean, yeah, there's a bunch of high-quality formats, some of which are lossless that you see in like the professional video and video editing world. There's also a lot of formats which are not quite lossless, but have like fairly minimal and predictable compression artifacts. So you'll hear about formats like, what is that one that, like DNX HD and ProRes are I think two of them. DNX HD is the one I usually use for editing. ProRes is Apple's, and I used to use that one. And those are compressed. They're not lossless. They're just pretty minimally compressed. There are video formats that are lossless, but they're a lot rarer because you need like special fast hard disks. I mean, nowadays you have NVMe SSDs, and those are fast enough for whatever. But before that came along, you would have needed like special hard disks, so that's a lot less common. Actually, I need a quick restroom break, so I'll leave you with the cat here, and I'll be right back. The robot is parked in this really inconvenient place right now. I'm like ducking around wires and climbing around cameras to get in here. I think Tuco wants food. I'm gonna have to take a break to make him some food in a bit, and I probably am not gonna keep the stream going that much longer. Didn't want to make this a super long stream, but I wanted to get something out, and I feel like the next couple days I was looking at my schedule, and it's like harder to find contiguous chunks of time where it's easy to stream, just because I've got like random obligations to deal with. So yeah, some of them are good, but you know, it's like hard to schedule stuff when so many of the things that you do need just like giant blocks of uninterrupted time sometimes. It's like you want to have like a quick phone call with someone, and all of a sudden that's like this giant rock in your schedule that defines whatever's nearby. Oh, this wire could be just a few inches maybe. I've already got these pre-wired ones, but that's super overkill. So we want something like that. I had all this goo on the old one to cover this blue LED, like black hot glue and black tape on the back. so just got the wires stripped regularly on one side. On the other side, I'm going to kind of fold them and put them in these solder cups and put heat shrink over that. Do I have my hot air gun hooked up? I do. Cool. That's too small. Ooh. That's too small. That is barely too small. That's the right size. That is 3/16 inch. What is an inch anyway? These are labeled minus and plus. There's a standard polarity for XC60s, thankfully. Because it would really suck if you just plugged a LiPo battery into the charger backwards, right? And it looks like these don't actually have much of a recess in the solder cup. So I might have to do something where I flux them and then stick them together. I could also maybe tape this down. I just feel like I probably won't get the alignment right unless I flux them and stick them together. It's a little less light than I usually have. So I'm just tinning the solder cups. Just trying not to overheat the plastic. And let's tin these. Trying not to shrink the heat shrink before we want it to be shrunk. And then a little more flux. Can I hold this in there? Kinda. That's handy. Alright, let's add a little bit of flux. Alright, so plus on this side, minus on that side. Okay. That one doesn't have much solder on it. did slightly shrink the red heat shrink. Oh well. I think it'll still work. And double check the polarity. That's minus, that's plus. Cool. Yeah, this heat shrink is plenty big enough, so a little bit of shrinkage is not a problem. This thing is heavier than you'd think it would be. So then this goes in the screw terminals in the DC-DC, and this plugs into the output. And then I think we can at least get this back on the network, even if the gimbal and the LEDs are disconnected. And that might be a good stopping point for tonight's stream. Yeah, this converter is rated at 5 amps output, which we're not going to need anywhere near that much, but that's nice that it is. We do even have a sensor to measure that voltage, which is kind of handy. It's built into the gimbal. It's one of the A to D controller or A to D converter channels in each of the gimbal controllers, each of the 3. I think just to keep the wires a little tidy, I can kind of loop it around like this. Yeah, and then if we want the microcontroller to work, we can plug these two 5-volt outputs in, although maybe we want to measure the voltages first. Let's turn on the power. The easiest way for me to do that is from my phone. Okay, so that should have just powered up the DC-DC. No explosions. Let me get the meter. Alright, 24.1 volts there. This will be the opposite polarity, but minus 12.2 volts there. You should see the same 12 down here. All of these should be different 5-volt channels now. just going to test one because I think everything is fine so far. Unless we had problems with some of these grounds, like that could explain some of the LED weirdness, but these connectors all look fine. So, if we are going to test the power quality, I'd want to do that on the O-scope anyway. That's like bang on 5 volts, so I think I can just hot plug a couple of these 5-volt connectors. Can I? Which one plugs in first, actually? I don't know if I want to hot plug any of this. Let me turn the robot off briefly. Do I have a script that turns only the flyer part of this off? I don't think I do. Let's turn the winches off too. I've only got a shell script on here that controls the winches and the flyer at the same time. One of the winch control, or one of the HS110s is timing out, which is not great. I thought they all had a pretty good Wi-Fi signal. What is the voltage here? 1.2 volts, I'm dropping. Alright. I'm going to plug in 2 of these 5-volt circuits. This should give us microcontroller and some basic sensors, as well as all the LEDs on the top of the thing should be on now, or after I turn the master power on. Alright, so the power just comes back on, except for the one that isn't responding. I think the one that wasn't responding stayed on. Alright. So the green light on this board is on. No LEDs on the top yet. Was I mistaken about that? Oh yeah, that's right. The LED power, as I was saying, comes through the bottom. So power for the LEDs on the top 2 rings, that's expected to come through this connector. So that is not currently powered. But yeah, the sensors and the micro should be on. So let's just check that out. Oh, is your domain not set? Oh, maybe it was 8080. I'm wrong about that. I sure thought it was running on port 80. Did we end up with a firewall on this machine again? Hey, Tuco. Oh yeah. Firewall settings. Alright. I know, Tuco, you're doing a great job of standing on zip ties. troubleshooting network connectivity right now. There we go. So the gimbal is not connected right now. Video recording is not operating. The winches are all here. And the other sensors, is that actually the orientation sensor? Yes, so that's the orientation sensor. I can like wobble that and it does its thing. And we have the lasers. These are the IR sensors. And here are the lasers. And there's the X-band. So that's the X-band. It's roughly measuring velocity of objects that it can sense reflections from. And then the LiDARs. Whoa, this is the LiDAR that's on the gimbal. So this one's not plugged in. But these are the top-mounted LiDAR. So you can get under each of those. And that works. These are the IRs, all on different charts. And they're just a bit noisier as a baseline because I need some shielding up here. So it's a little harder to make sense of what's going on here, but I should be able to get some reflections at least. Yeah. That's a reflection. There's a couple more reflections. This data needs a lot more processing, but it's something. Alright, well I think that's today's stopping point maybe. It's a little late here and didn't start the stream out with a ton of energy, so I think I'm going to put this away and just try to get some more kind of small streams in whenever I can. I might do some more of this work off camera too, since it's probably just going to be a little bit of mundane troubleshooting coming up, but yeah, certainly going to do more of this Tuco Flyer troubleshooting and maintenance and making it better and working on software and just all the stuff there is there. But we've also got some other projects going on. We've got several things we could be reverse engineering now. We've got some things that were sent in, like the Amazon buttons, like this this like medical device that's for kind of muscle stimulation. We've got this Tandberg C70, which is this massive video conferencing device with encoders and decoders. And we've got this old Blu-ray drive project, Coastermelt, where I was kind of doing a lot of work to make it possible to debug the firmware in this drive and lead toward an open source implementation. So yeah, lots on our plate. Certainly let me know what you'd like me to aim toward if there's certain projects that you find especially interesting. And special thanks to everyone who sends in hardware to work on, or folks who contribute to the Patreon every month to help keep me doing this on a regular basis. So yeah, I mean, I'm doing this for you, so if you want to contribute to the process and kind of direct what I'm doing, or kind of help me choose which projects to focus on, I'm open to suggestions there. And so let me know what you think, either in the Gitter chat or Patreon. If you're a patron, you can send me messages there. Twitter, Mastodon, everybody can send me messages there, for better or for worse. So yeah. And yeah, as Pio mentions, it's nice to have the virtual hackerspace feel sometimes. It seems like one of the benefits of doing relatively regular streams when I can do that, even if the work is kind of eclectic and all over the place, it can be nice to have a place that feels kind of like a virtual hackerspace. So yeah, thanks for hanging out, and thanks so much to everyone who contributes. I'll see you next time. If I can remember how to change the channel here. All my monitor setups changed. Happy hacking, everyone. I'll see you next time.